Hey Math 10C, so what are we going to do today? We are applying the trig ratios. So we are going to be pretty much adding everything we've learned up to this point from 2.1 to 2.5 all together, and we have to know when to use specific ratios, so such as like sine, cos, or tan, how to utilize our Pythagoras theorem, and then this last one here. So when we're dealing, let's kind of go over what we have in our tool trig box. Okay, especially for right triangles. This is mainly for right triangles. We have the three the three trig ratios. Okay, they will always relate an angle to specific side lengths of a triangle. You have Pythagoras, and remember the main important thing with this is that C has to be your hypotenuse. Okay, that's the big important thing. C has to be hypotenuse, and then these two guys are interchangeable. Now, this last one I really messed up on, the angles of a triangle. They do not add up to 360 degrees, okay? What they add up to is 180 degrees, okay? So please be aware of that. If you have a triangle, let's kind of draw it over here. And it can be any triangle, but we're pretty much in Math 10 always just dealing with right angles, okay? If we call this triangle ABC, the angles A plus angle B plus angle C, that equals 180 degrees. So it's really useful if you have two triangles angles, you can always solve for the third one. Okay? Now, so make sure you make that edit. Huge edit to make in this booklet, okay? Sorry about that. Now, what does it mean to solve a triangle? Okay? When you want to solve a triangle, that essentially means you want to find all angles and lengths. Okay, so pretty much, if you're ever asked to solve a triangle, it wants you to find everything you know about that triangle. Okay, so let's look at example 1 here. So solve the triangle ABC if C is a right angle, and then the measurements of A to C is 7 centimeters, and the measurements of B to C is 4 centimeters. So we have a triangle, and it's telling us it's a right triangle. So let's start off by drawing a right triangle. Okay, so there's my right angle. And in this, it tells us that C is a right angle. So this is going to be C here. Okay, so we have C there. And then we can make A this one and B this one. It doesn't matter too much as long as we follow the rules that C is the right angle. And then we can apply these measurements here. AC is 7 meters. A to C is 7 centimeters. And then B to C is 4 centimeters. So from B to C, it is 4 centimeters. Okay, so now we're trying to solve this triangle. So what do we have to do? We have to use what's in our toolbox. Okay, so these 3 points in order to find everything we know or everything we can about this triangle. So let's focus on finding A to B. Okay, so the first thing I notice is that side A to B is the hypotenuse. Okay, it is directly across from the 90-degree angle. So this is your hypotenuse. Okay, and that's really important to understand because when you deal with Pythagoras and when you deal with the 3 trig ratios, you need to know these things, okay, where the hypotenuse is found. So let's find A to B. The first thing I notice is that we have 2 side lengths and we're missing 1. If you ever have 2 side lengths and you're missing 1, then you go to your trig toolbox and that pretty much relates with the Pythagoras theorem. So let's use our Pythagoras. So that's A squared plus B squared equals C squared. Now remember, C always has to be the hypotenuse. So this automatically means A to B squared is C is A to B because it has to be the hypotenuse. And then C7 here can either be placed in for A or B. It doesn't matter which one as long as C is hypotenuse. So it'd be 7 squared plus 4 squared. Now, let's pull out our calculator, and remember, you should always be practicing plugging things into your calculator, okay? Because it takes some practice knowing where certain values are. So how do I plug in 7 squared? Well, what you're going to press is 7, and you're going to notice right above our cursor here is x squared. If you press this button, it squares your number there. So I'm going to press squared, and we can see that it has squared it. I'm going to add 4, and then I also have to square this. So I'm going to press the square button and press enter. So now I have 65. So this thing is 65 equaling a to b squared. Now remember, when something is being squared, in order to find the root of it, we got to square root both sides. So we're going to square root both sides. How do I square 65? So to square root, if you look back at your x squared button, in yellow, right above it, has a little square root button. How do I get to the yellow buttons? I press second, which is the yellow button. And now I have activated all the yellow writing. So I'm going to press the square root here and then plug in 65. And that gives me a to b equaling 8.06227 centimeters. Now I'm going to round this to 1 decimal place. So I rounded it to 1 decimal place, so this is my first decimal place. The number to the right of it is 5 or greater, so that means it rounds it up to 1. So we have found side length a to b, 8.1 centimeters. Now, let's work on solving for one of these angles. Okay, so let's maybe focus on finding angle B here. So find, I'll maybe do it in different writing. Find angle B. Okay, so let's look at angle B and let's look at all the things we're given in our triangle. So we were given 7 and 4. Recognize if I'm ever going to use this 8.1 in a calculation, I need to use the non-rounded value, which is found here. So it's always good to try and just use the numbers you were given, because they're not rounded, okay? If you use rounded values, you're going to get the wrong answers. So if I ever to use 8.1, I actually have to use 8.062257748. Okay, so to work around that, I'm going to just use 7 and 4. How does the side length 7 and 4 relate to this angle? Well, in terms of this angle, in terms of angle B, 7 is the opposite side length, and 4 would be the adjacent, because hypotenuse can never be adjacent. So thinking about SOHCAHTOA here, for angle B, this is opposite, this is adjacent. Which ratio relates opposite and adjacent? Well, that would be tan, TOA, opposite, adjacent. So that means I'm going to use tan angle equaling opposite over adjacent in my calculation here. Now let's write this in terms of angle B. So I'm going to put a little subscript on angle B here. Now we're thinking about it tan in terms of angle B. So for angle B, our opposite side length is 7, so that's A to C. So I'm just going to represent it as A to C. And my adjacent side length is from C to B. And now I can plug in my values. So what is side length A to C? A to C is 7. So let's plug in 7. C to B is 4. So let's plug in 4. Okay. Now remember, we're solving for the angle here. When you're solving for an angle, you have to take the inverse of the ratio. So that means angle B is going to be the inverse tan of 7 over 4. Okay, and let's plug that into our calculator. So if we go here, remember, how do I get to inverse tan? Well, if I just press tan, that's not what I want. I want inverse tan, and you can see in the yellow writing, there's inverse tan. So I'm going to press the yellow button second. That's activated all the yellow writing, and I'm going to press tan inverse. You can see it's popped up, tan inverse. And now I put in 7 over 4. please make sure you press mode just before you start doing things and make sure you're in degree mode. You don't have to do that every time, just make sure you're in degree mode or else you're going to get the wrong solution. Now that gives me 60.2551187. So 60.2551187, and that's in degrees. I'm going to round that because it's the final answer. I'm going to round it to one decimal place. So I need to round this 2 up to a 3 because the number to the right is 5 or greater. So this is 3 degrees. 6.3 degrees is angle B. Now, we've found angle B. How can we find angle A? Well, we could do another trig ratio, right? We could really do any of these SOHCAHTOA. We could use sine because we have opposite and we have hypotenuse. We could use cos because we have adjacent and hypotenuse. And we could use TOA because we have the opposite, which is 4, and the adjacent, which is 7. But I'm actually going to use this rule here, that the angles of a triangle add up to 180 degrees, okay? Because we have 2 of the angles now. We have angle C, which is 90 degrees. We have angle B, which is 60.2551187. And we are trying to find one angle here. So here, let's do it in another color here. Find angle A, we just have to remember that in a triangle, all 3 angles added together equal 180 degrees. Okay, and we can plug these in. Now, it's really important to understand, remember, we're not going to use this rounded number when solving for another answer. We have to use the non-rounded number, and I'm going to show you a way to put it into your calculator where we don't have to type it all out all over again. So first off, angle A plus angle C, which is 90 degrees, plus 60.2551187. So I'm just going to round it to 255, just so we don't run out of room here. Now, zooming into here, we can solve for A, right? A can be easily solved for. We just have to combine these and solve for it. So let's combine 90 plus 60.255 degrees. Remember, I'm not even using this rounded number. I'm using the whole number that was in my calculator. So how do I do that? I'm going to press 90. And now I have 90 up here, and I'm going to add the last number that was in my calculator. How do I get to the last number in my calculator? Well, if you look below my cursor here, you can see the word ants in yellow. Ants simply means the last number you solve for. So if I press second, and it activates the yellow writing, and I press ants, you can see ants pops up. Ants represents answer, aka the last answer you solved. So this is saying 90 plus ants, and ants in this case would be 60.2551187. So it's taking that whole number and adding it there. So that gives me 180, or sorry, angle A plus 150.255 degrees equals 180 degrees. And now we are going to subtract 150.255 degrees from both sides. And that's going to give me, well, again, I don't want to use a rounded number. I want to use this whole number. So I'm going to do 180 minus, and I'm going to press second, ants, because my last answer was the number I want to use. That's going to give me 29.744 degrees, and I'm going to round it to a decimal place. Or, one decimal place. So this will be 29.7 degrees. I don't round 7 up because 4 is less than 5. And now we have solved everything we need to know about this triangle. Now the coolest part, but sometimes the most confusing part, is that we could have solved these many different ways. We could have found the angle here using another trig ratio, right? We could have used tan all over again. We could have found this side length using a trig ratio. Okay, so there's always different ways to solve a triangle. Okay. Okay, so if any of that confused you, please rewatch the video. Take all these notes down, and if you want, you can come in and ask some questions. So let's move on. So we have a few more examples to go through. Let's look at example 2 here. So solve the right triangle where the side JK equals 8.3 centimeters and the angle J is 25 degrees. State the measures to the nearest tenth. Okay, so let's write down everything we have. First off, remember, we're dealing with the right triangle. As soon as you see that, where's your hypotenuse? There's my 90 degrees, and right straight across from it, you find your hypotenuse. So this equals your hypotenuse. Now, we can start applying our measurements. So J to K is 8.3 centimeters. So let's put 8.3 centimeters here, just so we're aware. And then angle J is 25 degrees. Okay, now it wants us to solve the triangle. AKA, we need to find K to M. We also need to find J to M. And we're also going to have to find angle K. Okay, so we have a bit of work on our hands here. Now, think about the easiest thing you could solve for right now. The easiest thing I see that we could solve for using our trig toolbox is I have two angles of this triangle. I can easily solve for the third. So angle K, let's find angle K. So remember, we're going to use this whole idea. All the angles of a triangle add up to 180 degrees. So let's use that. So I know that angle J plus angle M plus angle K is going to equal 180 degrees. Here we can simply plug those in. Angle J is 25. So let's plug 25 degrees in. Angle M is our 90 degrees. It's our right angle. And then we're solving for that angle K. Okay, we're going to add up 25 and 90. Okay, 25 and 90 give me 115 degrees plus angle K equaling 180 degrees. And we are going to subtract 150 degrees. Sorry, 115 degrees. Okay, so angle K here, let's make sure we've calculated all that right. Sometimes your brain, even though it might be a simple calculation, might mess that up. So we added 25 to 90, and then we took 180 and we subtracted 115. So this is 65 degrees. So angle K is 65 degrees. So we've already found something really fast. We found angle K. Okay. Now, let's look at what else we need to find. So I could even write that in here just so I'm aware. And the nicest part about this number is it wasn't any ugly decimal. So we can actually use 65 degrees happily when we're doing these. So let's look at what we need to find. We need to find J and M. So let's focus on that. So let's do it in kind of purple here. Find J to M. So how could we find J to M? Well, let's look at J to M. We have the hypotenuse, okay, and we have we have three angles, but we could use these two angles in our trig ratios. So we're probably going to have to use either so, we're going to have to use ka, or maybe we're going to use toa. Okay. Now we're given, let's use this angle here. Let's use 25 degrees in order to find JM. You could technically use this as well, but it's good to just, okay, I'm going to use this and solve for JM. So I'm going to use this angle. So let's use angle J, which is 25 degrees, to find JM. Okay, we also have the hypotenuse here. Okay, so we have the hypotenuse, J to K equals hypotenuse, which is 8.3 centimeters. And now, in the perspective of 25 degrees, what is J to M? Well, this would be the adjacent side. Remember, this cannot be the adjacent side because it is the hypotenuse. We determined that at the very beginning of the question. This is the opposite side length. this is the adjacent side length for 25 degrees. So in the perspective of 25 degrees, J to M equals the adjacent side length. So now we can try and determine which ratio to use. Well, we're not going to use tan because tan uses the opposite side length and the adjacent. That doesn't relate anything that we know of. The opposite we don't know, the adjacent we don't know, so that would not work. We're going to use the cos. We're going to use cos because it relates the adjacent to the hypotenuse. In this case, we're trying to find adjacent and we have the hypotenuse. So cos relates these two things by doing cos angle equaling adjacent over hypotenuse. So in terms of angle J, what is the adjacent side length for angle J? Remember, we determined that. In terms of angle J, it's J to M. So this will be J to M over, and what's your hypotenuse? Well, we found that at the very beginning, 8.3. Or we'll represent it as J to K for now. And now let's plug in our values. So cos, the angle is 25. J to M is what we're trying to find. And J to K is 8.3. And here, we talked about this in our previous sections, how to solve for J to M. So to solve for J to M in this case, we need to cancel 8.3 on its side. So I'm going to multiply by 8.3 over 1. And I got to do that to the other side. This cancels your 8.3 out. And we will get 8.3 multiplying cos 25. That equals J to M. Okay, so let's plug that into our calculator. Now remember, we're not solving for an angle, so we don't have to use inverse. We just plug it simply into our calculator. So this will be 8.3 times your cos button here and 25. So 8.3 times cos 25, and that gives me J to M equaling 7.522 centimeters. And now what does it want us to round to? State the measures to the nearest tenth. So the nearest tenth here would be this value, okay? And we're going to keep it at 5 because 2 is less than 5. So this will be 7.5 centimeters equals J to M. Now recognize if I were to ever use this number in a calculation, I have to use that whole rounded number. So you got to remember that. So J to M equals 7.5 centimeters. Okay, and we have one more thing to solve for. Okay, we still need to find K to M. So again, what could we use to find K to M? Well, now we have two side lengths, so we could use Pythagoras. We have these angles, so we could use these angles in a certain ratio that relates them. I'm going to use Pythagoras though. So a squared plus b squared equals c squared. Now remember, what's the main important thing about Pythagoras? It's that c has to be your hypotenuse. Okay, a and b can just be the other two interchanged. So c has to be hypotenuse. So this is going to be 8.3 squared, and I'm going to put a little reminder here, needs to be hypotenuse. Okay, so it has to be your hypotenuse. Now a squared, well, a squared, we could either make km or jm. Let's just make it jm. So 7.5, and remember, I'm not going to use the rounded value. So let's put a few here to remind ourselves that we can't use the rounded value. So it'll be 7.522 squared plus b squared. Okay, and we're going to open up our calculator, and hopefully you didn't clear it. Because remember, in order to use 7.522, we actually have to use this entire number. Now we're going to use that second ants kind of trick to solve for that. So I'm going to press second, and I'm going to press ants. And now remember, this ants is representing your last value, so 7.522, and I'm going to square it. So this gives me 56.585, blah, 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 plus b squared equals. Now, this is going to be a little tricky here. I'm going to show you one more calculator trick. I can store this number in my calculator. How can I store it? Well, what you're going to do is you're going to press second, and you're going to press the answer button again. Now I want to store this in my calculator. So on the bottom left, you're going to see STO. And now you're going to see an alpha button. So press the green button. And in your calculator is going to look a little different. It's going to have values in green letters that say A, B, C, D. And it usually starts here. A, B, C, D, so on and so forth. So I'm going to press alpha, and now press A. So now, anytime I press alpha A, it pops up that number. Okay, so I'm going to store this in my calculator as A. Okay, so if you weren't able to follow along with that, you got to come in and learn how to do that because it's super useful. And then I'm going to do 8.3 squared. So 8.3, and then I'm going to press my square button. So that gives me 68.89, and that's a nice number. That we don't have to worry too much about storing that. Now I'm going to start solving for b squared, so I'm going to subtract 56.585 from both sides. Okay, and I'm going to get b squared equaling, and remember, I'm not using this number, I'm using this gigantic number. So anytime I need to manipulate using 56.585, I'm just going to actually go alpha A, because this is representing A. Okay, so I'm actually going to plug in A here. So let's see it in my calculator. So I'm going to take 68.89, and I'm going to press alpha, or sorry, not yet. I'm going to press subtract alpha A, because remember, A is representing this big, ugly, long number. And that gives me 12.304, blah, blah, blah. And now to solve for B, we are going to square root both sides. So this will give me B equaling. And remember, how do we get to a square root? You press second, and you press that little square root button. And then remember, I want to square root this whole value, so I'm going to press my second ants. Okay, I'm going to get my last answer in underneath the square root value. So B equals 3.507 centimeters, and it wants us to round it to the nearest tenth, so this is 3.5 centimeters. Okay. So if that calculator thing confused the heck out of you, you gotta come ask and get that figured out because it is super duper useful. The biggest thing is anytime you store something in your calculator, make sure you remember to note it down. Now we have found all the angles, and now we've also found every side length. So we have solved this triangle. Okay, so let's move on. We've got 2 more examples to go. A lamp leans 3 feet off the vertical. The lamp is 127 feet tall. What is its angle of inclination to the nearest tenth of a degree? So we have a lamp 3 feet off the vertical. So what does 3 feet off the vertical mean? Okay, 3 feet off the vertical, if we draw this lamp leaning, okay, so who knows why you have a leaning lamp, but that's okay. You can imagine it creates a bit of a right triangle. Okay, 3 feet off the vertical means this is 3 feet. Okay, because if we pushed it 3 feet back, it would be now not perfectly vertical. The lamp is 127 feet tall, so this lamp is 127 feet. It wants to know the angle of inclination to the nearest tenth of a degree. So remember, we talked about angle of inclination in our last video. Angle of inclination is an angle that is made from the horizontal and it goes up. So this is the angle at question. So I'm going to just put a little question mark here. Okay, so we want to find this angle. We're given a few things. Recognize this is a 90 degree, and the first thing you can note is opposite to this 90 degrees is finding your hypotenuse. So find angle question mark. Well, remember you have SOH, CA, TOA. What relationship do these side lengths have to this angle? How do they all relate? Well, first off, let's determine what they actually are to this angle. So 127 foot, that's the hypotenuse. It'll always be the hypotenuse. And this 3 feet, that makes this 3 feet the adjacent. So what relates adjacent and a hypotenuse? The thing that relates adjacent and hypotenuse will be cos. Cos angle equals adjacent over hypotenuse. So we're going to use this guy. And now we can actually plug in our angle at question, which is our question mark. And in the perspective of our question mark angle, this is your hypotenuse. So I'm going to plug in on the bottom here, my hypotenuse is 127. And my adjacent is 3 feet. Ooh. So I don't know why I plugged in 3 feet there. Okay, and now we can solve for our angle. So remember, anytime you're finding an angle, you got to take the inverse of the ratio. So 3 over 127. So let's pull out our calculator here. And let's plug her in. So I'm going to press, second cos. So now I have inverse cos, okay, 3 over 127. And that gives me 88.646 degrees. Now, did it tell us what to round to? It says to round to the nearest tenth of a degree. So I got to round to this decimal place, the first decimal place. So my answer will be 88.6 degrees. So I'm not going to round it up because the number next to it, which is a 4, is less than 5. Okay, so with trig problems, you really have to think about what am I trying to find and what can I relate? Okay, how do these things relate to each other? And that's how I determined to use cos. Okay. Right on. Let's do one more question here. So example 4, determine the height of the left building. Okay, so this is our question mark here. Okay. So this diagram is a little confusing because it has 200 meters here and 200 meters here. The important thing to understand is that 200 meters is this height. 200 meters here is this height, okay? The tough part about trig is when they give you a bunch of different triangles to be looking at, okay? When you're given a bunch of triangles to be looking at, you got to think about, okay, what do I need to use? In order to figure out the height of the left building, which is the height from here to here, we'll need to figure out H2 and add it onto here. So let's write that down. The height of left building equals H2 plus 200 meters. So essentially this question just wants us to find H2. Because if we find H2, we can find the height of the left building. Now, how do we find H2? Because we're not really given much here. In order to find H2, we at least need one of these side lengths, okay? If you have one of these side lengths and an angle, you can solve this whole triangle. Now, looking at this, I notice that this side length is shared by this triangle. Shared side lengths can be really useful, okay? So I'm gonna actually put little values onto this, okay? So this is triangle, I'm gonna make this A, B, C, and I'm gonna represent this as D up there. Okay, so if I can find C to B, I can use that. If I can find C to B, I can use that to find H2. Okay, so let's focus on triangle CBA. Okay, use triangle CBA to find H2. Okay, so let's talk about that. If I draw out this triangle here, let's draw triangle CBA. Okay, so we have our 90 degrees. This is C, B, and A. This is telling us it's 20 degrees. And this is 200 meters, right? C to A is 200 meters. We're trying to find C to B because that shares in this triangle. So let's put a question mark here, okay, and let's start solving. Well, hopefully you can see we've made this a lot simpler, and now you have an angle, you have a side length, so we can determine which trig ratio to use. Okay, well, let's first off note everything that we know. So as soon as you get a right triangle, what do we find? The hypotenuse. The hypotenuse is opposite of that 90 degrees. So this is your hypotenuse. Now in terms of angle 20, okay, what is C to A? C to A is the opposite. And in the perspective of angle 20, what is this C to B? This is adjacent. Okay, so it looks like we have opposite, we're trying to find adjacent. What relates opposite and adjacent? The thing that relates opposite and adjacent is tan. So this is what we're going to use. Okay, so let's talk about tan. So tan angle equals opposite over adjacent. Okay. And now let's plug it in terms of angle B, okay, which is our 20. Okay, in terms of angle B, opposite is your C to A. Adjacent is your C to B, which is what we're trying to find here. Okay, so let's plug in the numbers that we have. So tan, angle B is 20, C to A is 200, C to B. And now we're solving for C to B. And remember, we've talked about how to solve for this bottom value. We always want the thing we're solving for on the top. We want it as a numerator. So I'm going to multiply both sides by C to B over 1. That's going to cancel out my C to B. And what that's going to give me is C to B times tan 20 equals 200. And then from here, we can divide tan 20 from both sides. Okay, remember we're dividing tan 20 to get it to the opposite side. And that's going to nicely cancel out tan 20. And we will get 200. So let's plug this in our calculator. 200 dividing tan 20. And that gives me 549.49, and what's this measured in? Meters. Okay, I'm not going to round this because we're just going to use this value again. Okay, so I'm actually going to store this in my calculator as A. So remember, you're going to press second, ants, and now we're going to press stow. We're going to store it in our calculator. Now we're going to press alpha A. Now it's stored as A. Every time we press alpha A, it pops that number up. Okay, so this is alpha A. Now we have this length here. this is your 549. This is what we just solved for. And I'm going to represent it as A on top to remind myself, okay, that I saved that in my calculator as A. Now, we have an angle in this triangle. We have a side length in this triangle. That means we can solve for anything we want. Okay, so let's draw the triangle BCD. So triangle B to C to D. Okay, we're trying to find D to C, because if you see here, C to D, C to D, C to D is H2, okay, which is what we're trying to find. We have C to B, we just found that, and we have this angle here. And again, it's just like last time. You're asking yourself, how do the things I'm trying to find relate to the things I know? Okay, so if we look at SOHCAHTOA, where's your hypotenuse found, first of all? Your hypotenuse is found right here, directly across from your 90 degrees. In terms of this angle, what is C to B? Okay, I kind of made that a little confusing. Let's put C here. So in terms of the angle 10 degrees, what is C to B? Well, it is your adjacent. C to D is your hypotenuse. Okay, the thing we have, the thing we need, how do they relate? Well, that would be through tan, opposite over adjacent. So we're going to use tan. Tan angle equals opposite over adjacent. Now let's plug in the things we know. The things we know is the angle, so tan, 10 degrees. In terms of 10 degrees, where's the opposite? The opposite is D to C. And the adjacent is your 400 or 549. But I'm going to put dot, dot, dot here because remember, we need to use the non-rounded value, okay? So let's solve for D to C. So multiply both sides by 549 over 1. 549 over 1, okay? Put it in brackets just so no confusion happens. That cancels out. And you get D to C equals 549.49 blah, 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 multiplying tan angle 10. So D to C is going to be alpha A. So we're actually going to press alpha A, because remember A represents this number, and I'm going to press tan 10. Okay. And that gives me D to C equaling 96.89. And what's this measured in? Meters. Okay. And remember, we don't want to round this value because the thing that we're actually trying to find is this entire length. Oops, sorry. This entire length here, which we talked about at the very beginning. We're going to have to take H2, which in this case is D to C. Okay, so this also equals H2, and we have to add 200 to it. So our final answer will be height of building, height equals H2 plus 200, which will be 96.89, and we're going to use the non-rounded value, meters, plus 200 meters, and that's going to equal, so here, remember, we're going to press, our last number is the thing we want to use, so we're going to press second, ants, plus 200, and that gives me 296.89 meters, and let's round that to the nearest meter. So the nearest meter is no decimal place, so this will be 297 because your 8 is greater than 5, so it rounds the number up to the left of it, meters. Okay, So we went through quite a bit. That's pretty much an entire review of everything that we've learned up to this point, and now we're using it all together. Remember, you have these 3 very useful tools in your trig toolbox to be solving for things. Practice plugging things in your calculator. It's the worst when students know what to do, they just don't know how to properly plug in their calculator. Now is your chance to go check your understanding. Remember, AFLs are not for marks. They're to check how you're doing, what you're understanding, and if you're doing very poorly, make sure you come in and ask questions. If you're doing very well, then you can move on to the next unit. If anything in this video confused you, please contact